Suppose there are three parallelograms A, C, D, E, F, C, D, G, H, C, D, B. There are three parallelograms which are standing on CD. It is the same base of these parallelograms, and these parallelograms are made between the same parallel lines AB and CD. In this case, the area of these parallelograms are equal, which are denoted by 1, 2, and 3. If the area of this first parallelogram is 20 cm square, then the area of second parallelogram is also 20 cm square. And the area of third parallelogram is also 20 cm square. The area of these parallelograms is same. The area of these parallelograms are equal because they are standing on the same base and between the same parallels AB and CD. They are formed between the same parallel lines AB and CD. So their areas are equal. This statement says this. Are you clear, the students? Now I am going to prove this statement. The parallelograms on the same base and between the same parallels are equal in area. How to prove this statement? We have given the parallelograms on the same base and between the same parallels. The parallelograms on the same base and between the same parallels are equal. Up to here it is given. Parallelograms on the same base and between the same parallels are given to us. We should prove or we should show their areas are equal. We should prove or we should show their areas are equal. In what case the area of the parallelograms are equal? The parallelograms which are standing on the same base and between the same parallels. We should show their areas equal. So now my students, let's make the parallelograms which are standing on the same base. Same base and between the same parallels. Here two parallelograms A, C, D, F, this parallelogram, and the parallelogram E, C, D, B are standing on the same base CD. According to the statement, parallelograms on the same base. The base of these parallelograms are same. The base of this parallelogram is CD. The base of this parallelogram is CD. Their base is same. Both parallelograms are standing on the same base CD and between the same parallel lines. They are formed between the same parallel lines AB and CD. This parallelogram and this is another parallelogram. This. To prove this, at first we should write given. What is given to us? We should write 1 number given. What is given to us? We should write. We have given parallelograms on the same base and between the same parallels in the statement. According to the figure, parallelograms A C D F and A C D F and E C D B. E C D B. These parallelograms are standing on the same base CD. Both parallelograms are standing on the same base CD, and between the same parallel lines, AB and CD. Parallelograms ACDF and ECDB. ACDF and ECDB are standing on the same base CD and between the same parallel lines AB and CD. It is given. Now, to prove, what should we prove? If the parallelograms are standing on the same base and between the same parallel lines, then their areas are equal in area. It means their areas are equal. We should show their areas equal. So to prove parallelogram, area of parallelogram or parallelogram, area of parallelogram symbol, this is the symbol of parallelogram, ACDF equals to the area of parallelogram, by symbol parallelogram ECDB. To prove, we should prove the area of these two parallelograms are equal, or we should show the areas of these parallelograms equal. Now proof. We should give the proof. To prove this statements and reasons. To prove this, at first we should show this triangle and this triangle congruent. My students, do you know how to show the triangles congruent? We have some condition of the congruency of triangles. They are angle, side, angle axiom, side, angle, side axiom, side, axiom, then angle, side axiom, and RHS axiom. RHS means right angle, hypotenuse and side. We have these conditions of congruency of triangles. If we show any one of these, then the triangles becomes congruent. Here we should show these two triangles congruent, triangle ACE and triangle FBD. Now in triangles, let's take these two triangles. In triangle AEC and triangle FBD. FBD. In these two triangles, which axiom can we show in these two triangles? Let's try. In these two triangles, at first I think this angle equals to this angle. They are equal because they are corresponding angle. These two lines are parallel. AC and FD are parallel, and this is the transversal, and this angle are corresponding angles. So these angles are equal. In these two triangles, our first angle equal. Such figure is there. If we separate the figure, such is there. These two lines are parallel. These two lines are parallel, and this angle and this angle, these angles are corresponding angles. They are equal. They are the parallel lines. So these angles are corresponding angles. So they are equal. At first angle equal. Then after, this angle equals to this angle. They are also the corresponding angle. Here EC parallel BD. EC and BD are the parallel. They are the parallel lines, and this is the transversal, so they are corresponding angle, so they are equal. Another angle equal. Next, this side EC equals to BD. EC side and BD sides are equal because they are the opposite sides of the parallelogram. ECDB is a parallelogram. We know that the opposite sides of a parallelogram are equal. So EC equals to BD because they are the opposite sides of the parallelogram ECDB. So side equal. By the axiom angle side. By the axiom angle side, these two triangles becomes congruent. So my students, let's try to show them congruent. One number. At first, angle CAE equals to angle DFB. Angle DFB. Reason, corresponding angles. Corresponding angles. And in 2 number, angle AEC equals to angle FBD. Angle FBD. They are also the corresponding angles. 2 number, corresponding angles. This. And in 3 number, we can show EC equals to FD. EC equals to FD. They are the opposite sides of the parallelogram. Opposite sides of parallelograms are equal. Opposite sides of a parallelogram. They are the opposite sides of a parallelogram, so they are equal. Look, this is at first angles are equal, second angles are equal, and third sides are equal. So by the axiom angle side, these two triangles are congruent. We have shown these two triangles congruent. By which axiom? By angle side axiom. So let's write triangle AEC congruent triangle FBD by angle side axiom. By this axiom, the triangles becomes the congruent. Now in 3 number, after the congruency of triangles, we can write their areas equal. If the triangles are equal, if the triangles are congruent, then their areas are equal. Their corresponding sides are equal, their corresponding angles are equal, and their areas are equal. So we can write here area of triangle AEC or triangle AEC. Let's write area of triangle AEC. Area of triangle AEC equals to area of triangle FBD. Reason? What is the reason? The reason is area of congruent triangles are equal. Area of congruent triangles. Area of congruent triangles. After showing the congruent, their areas are equal. Area of congruent triangles. Area of congruent triangles are equal. So we wrote this. Then in 4 number, now area of triangle AEC. Now triangle AEC. Let's write triangle AEC plus. In this side, let's add this trapezium. In between these two triangles, look, there is a trapezium. ECDF. It is a trapezium because its one opposite sides are parallel. It is a quadrilateral in which one opposite sides are parallel, so it is a trapezium. Let's add this trapezium with this triangle. Let's add this trapezium with this triangle. Let's add that trapezium ECDF equals to, we added the trapezium ECDF in this side, then in this side also we should add the same, then they can be equal. So triangle FBD plus trapezium ECDF this. 4 number, adding the trapezium ECDF on both sides. Now I remove this statement. Now 5 number, if we add triangle AEC and trapezium ECDF, this trapezium is added to this triangle, then this parallelogram becomes ACDF. When we add this trapezium with this triangle, what happens? It becomes the parallelogram ACDF. So the sum of these two, triangle ACE and trapezium ECDF, their sum becomes parallelogram this parallelogram or area of parallelogram ACDF equals to area of parallelogram, area of parallelogram, next parallelogram ECDB, ECDB, 5 number region from the statement 4 or whole part axiom from statement 4, from statement 4. Now it is proved. We showed or we proved the area of parallelogram ACDF equals to area of parallelogram ECDB. To prove area of triangle ACDF equals to area of parallelogram ECDB, it is proved. So at last we should write, hence the parallelograms on the same base and between the same parallels are equal in area. Now proved. Okay, thank you my students. If you have any comments and message, and if you have any curiosity, let's suggest me and comment.